Hey you guys, I'm going to talk you through the notes on 9-1 right triangles. Only one part of this I think is new. I think the rest of it, like most of this you know, okay? So get this out, fill it in, and of course I'll help more when I get back. You'll have this work to do and I have another worksheet. Okay, first real quick before we start, let's talk about what a right triangle is. So you know you have to have a right angle, which is 90 degrees. Okay, this box, I always say the box sits on the legs. So this is a leg, the box points to the legs. This is a leg, and then opposite of the right angle is the longest side, and the longest side is always called the hypotenuse. Long side, long word. Okay? That's what we got. Leg, leg, hypotenuse. Now, you guys are used to writing the Pythagorean theorem says that the length of the leg squared plus the length of the leg squared equals the length of the hypotenuse squared. You guys are used to seeing A, B, C, and you're used to seeing A squared plus B squared equals C squared. That's what you're used to seeing, okay? This is one of the most practical theorems that you will learn. And it's one of those, you go, what are we going to do with this in real life? Pythagorean theorem is real, and you can use it. Okay? Instead of saying A, B, and C, I'm going to say leg squared, hypotenuse squared. And really, I'm referring to the length of the leg, the length of the leg, the length of the hypotenuse. And I'm going to put the hypotenuse first because of the other work that we're going to come to when we talk about the Pythagorean theorem, inequality theorem, okay? So I'm going to say, for a Pythagorean theorem, it always is the length of the hypotenuse squared equals the length of the leg squared plus the length of the leg squared. Always, okay? The length of the hypotenuse squared equals the length of the leg squared plus the length of the leg squared. Again, I'm putting hypotenuse first just because of where we're going. Okay? Now, triples, when we talk about Pythagorean triples, these are numbers that fulfill this theorem, and they're whole numbers. Okay, so these are whole numbers that work for this. So this one here, 3, 4, 5, the long number has to be the hypotenuse. So if I were to check this, does 5 squared equal 3 squared plus 4 squared? And look at 25 equals 9 plus 16. Okay, this is a Pythagorean triple. It satisfies the Pythagorean theorem, and they're all whole numbers, right? They're positive integers. So this is a big deal, 3, 4, 5, and that's easy to memorize. It's something that's good to know. This is another Pythagorean triple, another one, and another one. Now you could take these and take multiples of them. So I could go 3, 4, 5. I can multiply them all by 2, and I could get 6, 8, 10. That's another triple. I can multiply all of these by 3, and I get 9, 12, 15. And if I plug them into the Pythagorean theorem, it proves to be true. Okay, these are all big deal. So these are numbers that work in the Pythagorean theorem, and they're always going to be whole numbers. Okay? Now the converse says, so if it's a right triangle, okay, I should have written this here, okay? If you have a right triangle, then you have this, okay? If you have a right triangle, then the length of the hypotenuse squared equals the length of the leg squared plus the length of the leg squared. That's your if-then conditional statement. Now the converse says, if the length of the long leg, the long side squared equals the length of the short side squared plus the length of the short side squared, then the triangle is a right triangle. So if I just give you 3 numbers and say, hey, is it a right triangle? You'd have to plug it in. Does the long side squared equal the length of the short side squared plus the length of the short side squared? If the right angle is not drawn in, you don't know. You cannot assume it's a right triangle unless you're told it's a right triangle or that right angle box like is told to you that way or it's told in the directions. So let's say I just have an 8, okay? And let's say I have a 5 and a 12. And I go, is this a right triangle? So you're going to take the long side squared. Does it equal the length of the short side squared? Does it? Is this true? So my long side, this is long, short, and short. So 12 squared. Does it equal 8 squared plus 5 squared? So this is 12 times 12. You could use your calculator, and you could go just 12 times 12, okay? Or you could go 12 and hit the x squared button right here, right? X squared. And that gives you 144, okay? Okay, 8 times 8 is 64. Like 8 and 8, 2, you got sick on the floor. 64 and 25. So 64 plus 25 is 89. Does 144 equal 89? No! Not a right triangle. Okay? So that's what we're going to do. Now, this is new here. This is all the way new. Okay, so I want you to think for a second. I'm going to try to find something that's a right angle here. I should have planned a little better. Okay, I'm going to find 3 lengths and lay them next to each other. So, okay, I've got a length, and I've got another length. Okay, I need to get one more length here. And I've got another length, okay? Okay. So when I put these 3 together, let me move it up here. Okay? We're going to say this is a right triangle, okay? But if I make this would be a leg, this is a leg, this is a hypotenuse. If I make my hypotenuse longer, the long side longer, now I would have to open up the angle. I would have to open it up bigger to accommodate for this longer side, okay? If this side is too long to be a right angle, then this angle has to be more than 90 degrees, okay? Let's look back at it again. We're going to say this is a right triangle. We're going to say 3, 4, and 5. That's our lengths. This is 3 long, this is 4 long, this is 5 long, okay? Now, I'm going to take this side instead of going, because 3, 4, 5 is a Pythagorean triple, so I know that's a right triangle. If I make this side longer, and I still have 3, 4, but I'm going to change this 5 into a 6, okay? In order to have this 6 for the third side of my triangle, I have to open, well, 3 and 4 is not going to, yeah, 7. Okay, I'm going to have to open this angle bigger. So if this long side is too long, this is obtuse. It has to be an obtuse angle and not a right angle. It's got to be more than 90, which is obtuse. Okay, let's write a couple things down. Okay, first I'm going to write down what does obtuse, an obtuse angle is more than 90. Acute angle is less than 90 degrees. Okay? Now, here's what, remember how I said I'm always going to put, because it will help you with this work. I'm putting the hypotenuse equals leg squared plus leg squared instead of writing it this way. That's because of this, okay? If you take the long side and you square it, and it equals the sum of the short side squared plus short side squared, then it's a right triangle. But if this long side squared is more than the short side squared plus the short side squared, I'm almost done, then this triangle is going to be obtuse. It's an obtuse triangle, okay? This angle is going to be more, the angle is obtuse, the opposite angle of this long side. If the long side squared is less than the short side squared plus the short side squared, okay, then this is going to be an acute triangle. Okay, let's look at some of these. I don't know what I do with my pen. I'm just going to look at a couple. First, let's solve, do some algebra together, okay? You have to remember that x squared and the square root are opposites. So squaring and square root are opposite operations. Okay, I always want to isolate my x squared, so I'm going to, this means 25, right? I'm going to subtract 25. So I'm going to have x squared equals, now x equals the square root of 119. Okay, watch me do it on the calculator. I've got 12 squared, and you could either go 12 times 12 or hit 12 squared, right? I'm subtracting my 5 squared. I've got 119. Now I'm taking the square root. The square root is opposite of x squared right here. You have to know that. Because I want it just to be x, I have to do square root of x squared. So square root is this above the x squared key. I have the square root symbol. So I hit second. Oops, I'm going to clear. Second. Now, can you see the square root? And I'm going to punch in 119, and I get x equals 10.91. So that's what x would have to be in order for this to be a right triangle. Okay? Let's try on this one, x squared is on this side. So you're going to go ahead, 3 squared is 3 times 3. 4 squared is 4 times 4. 25 equals x squared. Now I want to do the inverse of squaring, so I have to do square root. So you're going to, what number, what times what is 25? What is the square root of 25? So you're going to do the same thing. Second, hit that square root, that square key, so the square root function works, right? You're going to hit second and the x squared key, so we get this square root function. And then I punch in 25, and I get 5. Now notice that's one of your triples. 3, 4, and 5 is one of the Pythagorean triples. Okay, you guys try these. This one's a little tricky. Okay, see what you got. Now on this, okay, the box sits on the legs. This is a leg. This is a leg. The long side is always a hypotenuse. So when I do this, I'm going hypotenuse squared equals the length of the leg squared, length of the leg squared. I'm going to plug it in. So x squared equals 6 squared plus 4 squared. So you guys can go ahead and do that. I'll do also number 2. Number 2, box sits on the legs. This is a leg, this is a leg, this is a hypotenuse. Hypotenuse squared equals leg squared plus leg squared. Okay? So this time, h is 5. Your leg is an x, and your other leg is a 3. So this time you're going to solve it. So you're going to either solve it one of these two ways. That's why you've got 1 and 2 for your examples to look at. Okay? That's all of these. This one here, you're doing, this question's inside, just set up differently to make it hard, right? Leg squared, hypotenuse squared. Oops, sorry. On this one, there's your right triangle. So you're still doing leg squared plus leg squared equals hypotenuse squared. So your legs will be 13 and 6. Your hypotenuse will be x. Okay, I'm going to flip it over. Okay. Tell whether the triangle is a right triangle. So now you're going, is it? You're checking. Does the long leg, the long side squared equal the length of the short side squared plus the short side squared? That's what we're checking. So in this one, so some of you guys aren't going to know 3 times the square root of 34, how long that is. So I'm going to punch it on my calculator. I'm going to go 3 times, and I'm going to go second square root 34. This side is 17 long, so that's my long side, 17.49. So when I do this, I'm going to go short side, long side. I'll do this one for you, okay? So I'm going to go, okay, this long side, 3 times the square root of 34 squared. Does it equal the short side squared plus the short side squared? Are they equal? So I'm going to square my 3, that's a 9. And then square root of 34 times the square root of 34 equals 34. Does this equal 81 plus, isn't that 225? 15 times 15, 225. So 225 plus 81 equals 306. 34 times 9 equals 306. So is it a right triangle? Yes, it is a right triangle. Okay? So you guys are doing that with these. You're trying to figure out, is it a right triangle? Okay? Now, these, is it acute, right, or obtuse? That's the question. So you're going to take the long side and the short sides, right? And we're going to find out what goes here. Is it equal, greater than, less than? Okay. So when I look on this, 36 is more than 25. So that means instead of my angle being opened enough just to be a right angle, that angle's opened up too much, and this is obtuse. Okay, and we should have looked at it first. I don't know if you guys will remember. Is it a triangle, period? If it's going to be a triangle, 2 sides always have to be longer than the longest side. So just check out the long side, like 3.5. Does 2.1 plus 2.8, is it long enough to be a triangle? Yeah. 7.4, if I add these together, I get 6, 7.4. This one will not be a triangle. Look at it. Okay. So, and then down here you have more. This is just, this is on here twice. Sorry, you guys. I copied and pasted the same thing twice. You don't have to do this. Okay, I'm going to have one more worksheet just about right triangles. See what you guys can do. I think it's enough. Okay, help each other, please. Thanks.